Michelene Chi's work has deeply impacted all three of those fields, a unique and uncommon contribution. Recipients are acknowledged for having contributed substantial career achievements in educational psychology for this award, but we recognize the breadth and depth of Dr. Chi's contributions to the field of education. The award is given for original scientific, empirically based research that contributes significantly to knowledge, theory, or practice. Here again, she's nailed all three. It's interesting to share with you that this year, Dr. Chi also received the AERA Award for Distinguished Contributions to Research and Education, another of the most prestigious research awards given to living recipients. Dr. Chi's work is both broad and deep. To summarize it in a sentence or two is virtually impossible. She has done work that I have followed for years in discourse, problem solving, and broadly attacked the field of learning, including deeper learning. For many of you, you're already familiar with her work. For those of you who are not yet familiar and for whom this is your introduction, I invite all of you to enjoy Dr. Michelene Chi's presentation.
So it's going to be a theoretical framework about how we can engage students to promote deeper learning. So the deeper learning part is important. So the outline of the talk is I'll talk about the theory a little bit. That is published, both those papers describe it in progression of it. We're going to talk a little bit about the evidence and then how we're going to translate this into a theory of instruction and some results from our actual practice in the classroom. So what does engagement mean? So there's several grade sizes people talk about when they study engagement. The larger grade size is usually from a motivation perspective. So for example, are kids attending classes, are they doing homework? What I'm going to propose is looking at in a smaller grade size that I call cognitive engagement. That is, once you come to the table to learn, how do we engage you? How do you encode the instruction, instructional content, and the instructional activities? How do you engage? And that's what I'm going to be talking about. So cognitive engagement is not well defined. It's typically defined in terms of the cognitive processes. For example, people talk about the non-processing, the depth of processing, the use of more elaborate strategy, metacognitive reflection, and so on. So these definitions typically relate the cognitive processes to amount or quality or level of engagement. But it's difficult to say, outside of a laboratory study, what is the cognitive process that students are engaged in. So what we propose is that to define cognitive engagement by students' overt behaviors and products. So overt behavior is something that teachers can see, they can detect them, versus cognitive processes we know is covert. Behaviors are malleable at the student level, and students' behavior are easier goals for teacher to try to elicit and manipulate. And behaviors are also concrete measures that are easier to assess for engagement than covert cognitive processes. So the goal of this research is first to define engagement using concrete operational measures to figure out how to promote learners to be more engaged so they can achieve deeper learning, which is really important here. And can we teach teachers how to promote and elicit greater engagement from their students? So by deeper learning here, I'm not talking about the processes of deeper learning. I'm simply talking about the outcome, that is, can you answer harder questions, content questions? Can you get justification and causal reasoning and so on? So what is typically thought of as a cognitively engaged learner? Well, from lay people's perspective, it's really a binary choice. They think of students as either off task on the left or they're on task. So for example, this cartoon says, the teacher is Einstein, stop fooling around and pay attention. So paying attention is what most people think about as being on task. So on-task engagement from my perspective can vary in a continuum and can be experienced distinct behavioral modes. So the taxonomies that I'm going to introduce is defined strictly from the student's perspective as a function of what the students do and the products that they produce. Okay, it's very, very literal, the definition. The taxonomy is universal, applies to all domains, content area, age group, context in the classroom, online learning in the laboratory, and so on. So, as I said, we're going to differentiate into 4 behavioral modes, as I'm going to call it. The characteristic that we can think about is whether students are attentive, whether they're manipulative, whether they're generative, and whether they're collaborative. Okay, those are the 4 sort of characteristics. And the behaviors is that an attentive one, they're overtly passive. They're just, I'll give you a lot of examples later. So because they're overtly passive, I just call that passive. And manipulative, usually they're physically manipulating things. Let's call that active. Generative is when they not only are physically active, but there's evidence in their product of generating something new. And this is something new to yourself, not new to the content domain. And finally, collaborative is when you physically collaborate, active and interacting with someone else. And I'll have a lot more to say about that mode. It's quite complicated. So here's some example of what it means to be paying attention. You're paying attention, receiving instruction, just like what that cartoon said. So you could be listening, you could be watching your video, you're observing a demonstration, you're reading words on example. You're definitely paying attention. The second one is manipulative, in which you are physically manipulating something, such as copying a solution, underlining some important sentence, clip and pasting, pouring quantities, pointing, repeating definitions, selecting an option, moving a slider when you're in an online environment. All of these are active. Now, constructive or generative is one of the next really important mode. This is the one in which you actually not just manipulate instructional material, you actually generate something that's a little bit, generate something new beyond what the instructional material was provided. So you could be drawing a concept map when no concept map was presented. You could be self-explaining, explaining to someone else. You could be posing questions, taking notes in your own words, providing justification, making predictions, and so on. There's lots and lots of examples of generative behaviors. So all this means is that you're generating something that the material didn't provide. So it's not discovery learning. You're not discovering some new principle. You're just generating a little bit of knowledge that wasn't shown, okay? Wasn't given. So obviously, sometimes the same physical behavior needs to be confirmed by some external product in order to differentiate. Let's say whether somebody is taking notes in a manipulative way, that is, they just copy some notes, or whether the notes actually contain new ideas. So when it comes to generative, sometimes you have to actually examine the product to see which one it is. Okay, collaborative is when you work with a peer, but in a co-constructive way, meaning that not only is each person, each of the partner, constructive and generative, but they construct and generate upon the other person's contributions. So we call this co-construction. So it could be explaining to each other, arguing, reciprocally teaching and discussing and so on. Okay, this last one, collaborative interaction, is the most complicated because it's complicated to achieve the co-constructive nature of it, because there's at least 5 other peer interaction patterns that are not co-constructive. For example, you could be actively paired up. You could be cooperative, doing cooperative learning. That means you divide and conquer. You could have one partner, which is very typical, dominate and be generative and constructive, whereas the other partner simply agree and say, yes, that's just being active. Both partners could be constructive and parallel. That's already pretty good. You could get them both to be constructive. And finally, of course, they could interact socially. So there's various patterns of behavior, interactive behavior that you can look at, and most of them are not co-constructive. So one of the current challenges we're facing is that how to assess co-constructive or co-generation in real time, especially by a teacher, but maybe we have time to go to that. So we could do it by analyzing dialogue. And so in one of our forthcoming papers, we've used ICAP to analyze dialogue. Oops, I can't go into that right now. So if you look at meta-analysis of collaboration, at least 25% of studies do not show an advantage. And my claim is that one of these other 5 patterns is going on. Okay, back to ICAP. So we can conjecture and kind of assume that each behavioral mode elicits some kind of cognitive processes, but these are just conjectures. So for example, if you're just paying attention, you could be storing information directly. If you're manipulative, that means whatever you're manipulating could be activating prior knowledge, and then you can assimilate information to that prior knowledge. If you're generative, that means not only are you assimilating information to priorly activated schema, let's say, but you're making inferences on top of that. And then collaborative, of course, you're making inferences on top of the other person's contributions as well. So therefore, you can actually generate something novel. That's when creativity can happen. So basically, if you make those cognitive assumptions, the knowledge outcomes is that you might get inert knowledge for storing, complete knowledge, complete schema, let's say, more enriched and generative, and for collaborative, enriched and creative. If that is what you think, then both the behavioral modes and the cognitive processes, one subsumes the other, both of them gives us this ICAP hypothesis. That is, the interactive is better than constructive, better than active, and yet better than passive. So that is, we assume that as you go up these ICAP modes, you acquire deeper learning. And then if you stay in the lower 2 modes, you acquire shallow learning. Okay, I want to give 4 nuanced points about ICAP, and maybe some caveats. The first is that ICAP is defined strictly from the student's perspective. So how student engaged can be conceived of as independent of instruction. The instruction is provided. So, for example, on the left, the yellow, it says the instruction is the teacher explains and works out a problem on the whiteboard. If the teacher is doing that, the student could be doing either passively listening, actively copying down what the teacher says and justify why, or copying down and justify and discuss with a peer. So for the same instruction, you can have 4 modes of student behavior, right? So this makes you wonder about the debate in literature between direct instruction versus discovery learning. If you look at that literature carefully and look strictly at what the students is asked to do, whether in direct instruction or discovery learning, then all the data makes sense. There is no debate. Okay, the second nuance point is that, as I already alluded to, there's not a perfect correspondence between overt behavior and plausible knowledge change or content process. It's only more likely. I can't guarantee that if somebody who's just looking at a laptop isn't thinking deep thoughts, right? We all know that. But all I'm saying is that probability-wise, because it's more likely, on average, you're going to learn more if you did a higher modes. Okay? And within a class, if more students did the higher modes, the class will learn. So it's a probability thing. The third point is that there seems to be much more of a juncture, that is that we're interested, I think that's an important one to look at, between constructive and active. So I separate the two. So constructive and active clearly is can achieve deeper learning, whereas passive and active achieves shallow learning. But the one point we need to say is that in order to get deeper learning, it's really important for the assessment that teachers give to the students have deeper questions, right? So without deeper questions, you can't assess for deeper learning. That turns out to be a really important finding. The second point is that there are many, this is a point that people miss when I talk about even self-explaining, that not all domains need deep engagement. So, especially if you're trying, let's say you learn a procedure how to use an ATM machine, you don't really need engagement, you just memorize the steps. And for many grammatical rules in foreign languages, you don't need deep constructive interactive because there's no rhyme or rules for a lot of the grammatical. So if you look at people learning grammars and they try to test whether self-explanation is effective, they won't. Okay, the fourth point is that ICAP is makes very broad stroke categorization of these modes of engagement. I cannot differentiate between activities within the same mode. Obviously, if you start analyzing cognitive processes, some will be more complicated than others. might require less content process than forming a hypothesis, let's say. So I can't make predictions within a mode, but we can make predictions across modes. Okay, so now I'm going to talk about evidence. I'm going to talk about 4 kinds. So meta-analysis, classroom studies, laboratory studies, and our own study. So let's look at a meta-analysis. This meta-analysis just came out a year ago and it got a lot of attention. So it's a meta-analysis of 225 college studies, all in STEM. And what they found was that active learning was much better, improved students' learning by half a standard deviation, reduced failure rate and everything, which is consistent with ICAP. The reason it's consistent with ICAP is because active learning actually, which is a very popular term in college level literature, active learning actually encompasses interactive, constructive, and active, because it's defined by whether or not lecture was given. So without lecture means active, lecture means passive. So that was a very significant finding that people really pay attention to. Now I'm going to talk about classroom studies, and what I'm going to do is basically compare ICAP's prediction by first looking on the left side. So let's say it's a constructive, the intervention is constructive on the left, and then see what the other comparison is, whether it's passive, active, constructive, or interactive. Or whether we predicted the 2 concepts of the same modality, same mode, then it might produce the same amount of learning. So classroom interventions typically have lots of different interventions, right? And it's really hard to nail down exactly what it was. But sometimes the control condition is pretty easy to decide, so you can make decisions. So for example, a study shows that cooperative groups, which is interactive, learns more than a traditional lecture. Well, that's almost the same as what we just showed, right? The overall act is better. Or you can look at results such as peer tutoring, which is better than filling out diamond notes, which is active. Or you can look at results, studies that give you no results, in which summarizing your own words is as good as generating questions. Why do you get a no result? Well, from my perspective, they're both constructive. Comparing one constructive with another constructive, so you should get no results. Okay, next we're going to look at laboratory studies. Many of them are psychological studies. These are all studies from other researchers. What we're going to do is reinterpret the conditions in terms of what the learners or the participants are asked to do. I'm going to ignore what the researchers' questions is and their interpretation. And then I'm going to make pairwise comparison for all those studies that I can cleanly reinterpret. And so these studies measure learning and performance and so on. So I'm going to give you 2 examples of how we reinterpret these studies. It was really simple. I mean, I just went to all the learning science and health science and journals and just start looking at all these studies. So here's one which is very easy to explain. 3 people are discussing a complicated topic on radar, and these 3 people's discussion is videotaped. And then this videotape of the discussion is shown to a student who's observing. So, what do I do with the 3? The 3 conditions are explain. Explain condition is one in which one of the actors in the video turns to the camera and asks the observing student a question. Well, the observing student has an answer, so I would reinterpret that as a constructive condition. The second condition they call listen, in which one actor asks the same question but turns to another actor in the video and the other actor provides an answer. So the observer actually gets the response and the feedback as a listen. But I would interpret that as a passive condition because he just received feedback. The observer wasn't doing anything. And finally, you have the control condition where no question was generated and the observer, and therefore no feedback was given, therefore that remains passive, but passive without feedback. So we know feedback is always better than no feedback, but then from my interpretation, you're comparing constructive versus passive. So let's see what the results they got. So this is the results they got. The highest, the darkest line on top is the explain condition. So the left part is immediate recall, and the right dots are for 1 month later. We call it robust learning, it's delayed recall. So if you explain, you perform a lot better than the second one, in which you get the feedback, you heard everything. So when you hear everything, you can recall, you can do shallow, you can learn shallowly, but you can't remember after a month. Okay, so that would be how we would reinterpret a study. Here's the second example. This is taken from a developmental award, Michelene Chi, in fact she's winning an award here. So what Christine did was show preschooler this little crank device. As she cranked the device, the crank device that has a crank causing the gears to move, as well as a popper piece that you should ignore. It doesn't do anything. So she asked kids, I think they're 4 and 5, to watch as she cranks it for 40 seconds, or to watch and explain how you think this thing works. No feedback or anything, also for 40 seconds. Then she looked at the causal explanation. So the first study is on the left. I don't know why it doesn't show the gray. Anyway, the red line shows the frequency of correct causal explanation, and the gray line is the frequency which they were able to exclude the irrelevant topper. But in both studies, and the right is study 2, where she looked at explainers. Explainers also could give better justification. So explainers versus people who just describe. Explainers are constructive, describe versus active. And on the left is explainers who explain versus watch. So both those results support the ICAP prediction. So it's with this method of reinterpreting that we look at lots and lots of studies out there, and then we can get easily over 100 studies, maybe 200 by now, where we can just fill them into the cell where one condition may be constructive, another condition may be whatever else it is. So for example, building a concept map, which is constructive, is better than reading a text. Peer tutoring, like I said, is better than filling out guided notes, and so on and so on. And you can even look at triple comparisons in the literature. They don't happen very often. This is work by Janet Gobert, and these are just 2 different measures, but it's the same 3 conditions. Either you read only, you summarize, which is usually active, or whether you do diagram, which is usually constructive. So you go from passive, active, constructive, and you get the improvement. Okay, one more piece. So it's usually when you have a theory, it's more important to test your theory by explaining results in the literature rather than your own data, right? But we wanted to test all 4 of those in the same setting, so we did it in a college engineering classroom where we manipulated the 4 kinds of activity that students do to make it short. The 4 activities where they either read, they underline, they explain, or they explain jointly. And for each condition, we get 8 to 10% improvement from condition to condition. Okay, so all I've done is explain ICAP, explain the data that support it. Now I'm going to talk about the kind of how it can serve as a tool. We've been using it a lot as a tool. The first thing it can do is it can interpret a lot of discrepant research out there. So for example, if you look at a strategy like summarizing, some studies show summarizing is good, some studies show summarizing is not good. You can't make any sense out of it. At least as graduate student, I couldn't make any sense out of it. But if you put an ICAP lens on it, the ICAP lens does 2 things. One, it looks at how that strategy is implemented, right? So summarizing can be implemented as copy and delete, which is an act of summarizing, or summarizing in your own words, where you spin with the interpretation. So depending how it's implemented, and depends on what is the control condition that you're comparing it to. Once you look at those 2 things from an ICAP perspective, a lot of discrepant data makes sense. Okay, so we've used it as a tool. We've used it certainly as a tool for people to think about designing the control condition. If you want to make the claim that your intervention in school is better than another intervention, you should make sure that your control condition is in the same ICAP level. Otherwise, you're just comparing different levels of what students have to do. We use it now a lot for coding of data, and it seems to us in our latest paper that if students are more motivated, they tend to be more constructive, generative, and interactive. That's the data we found right now, which you can change it to. And the third thing, which is curious that I we haven't pursued it because we don't know how to do it yet. We taught them how to design deep questions to assess their lessons, which teachers couldn't really do very well, right? Because we didn't know how to teach it. So this was assigned, the school liked it so much, it was assigned as PD for all the teachers in the school. And afterwards, 13 teachers participate in our quasi-experimental classroom study. This is what we asked the 13 teachers to do. For each teacher, they created 2 or 3 lessons on a different topic. Each lesson is a topic. And for each lesson in blue, that's one lesson, they teach it to 2 different classes, the 2 green. So that's a pair of classes. So let's say they do a lesson on radar, let's say, and they do one lesson in interactive, one lesson in active. So basically they're designing their quasi-experiment. So here's an example. On equivalent expressions for one of their activities, what they manipulate some unique activities. So for the active class, they have card sorting. So students just simply move things around. They didn't produce anything new. For the interactive class, they have to generate what is different representations for 3/4. So it's very clear the 2 are very different on the same topic. So each teacher designed these activities. And then we assess the success of our translation or professional development in 5 different ways, from beginning to the end. I don't know any other professional development that has all these steps, but anyway, we try. We look at a teacher's learning, the transfer of teachers' learning to their design, the transfer to their learning to implementation, students' enactment, what the students actually do, and then students' learning. So I'm going to run through these 5 sets pretty quickly. First of all, the leftmost column shows as if the teacher did understand IM. But then when we ask deeper questions, the second 2 sets, and more discriminative questions, you can see that they barely reach 60%. So they didn't understand the nuance of ICANN. Mostly our fault, so that just shows you they didn't get it. The second thing we want to do is we want to see how well they can design their activities. So each lesson has usually, on average, 3 activities for kids to do. So we want to be very objective, so we analyze the written instruction they gave for the activities, right? So how do we decide that? So we analyze, within the written instruction, we analyze the verbs the teachers use. So on the left, you could think of those as active verbs, like avoid, bend, circle, click, confirm, copy, cover, cross out, delete. We think of these as active verbs because they don't add any new information. Constructive verbs are things like ask questions, build, brainstorm, comment, compare. And the interactive questions on the right. The first thing to notice is that they have 55, we can capture 55 active verbs, only 27 constructive, only 9 interactive verbs. That's the first thing we notice, which we were not expecting. Granted that when we actually do the coding, we're a little bit more careful than that. So if you use the word connect, we look at what you're connecting. Are you connecting 2 ideas, or are you asking to connect 2 nodes? Connecting 2 nodes would be active, connecting 2 ideas would be constructive. Based on this kind of coding, this is the result we got from the teachers. Written instruction. The x-axis in the capital is the class the teacher intended it to be. So on the leftmost, they intended the class to be active. In the middle, they intended the class to be constructive. The end is our sample. Just don't worry about that. So in order to compare across samples, we can use proportion. The thing you want to notice is that they're pretty active classes. They generate a lot of active verbs in their instruction. But for constructive, they don't even, hasn't even approached, it's barely 50% constructive verbs. But most interestingly, for collaborative, interactive classes, only 7% of the verbs used are collaborative, interactive construction. So they're really weak on interactive and not even that great in constructive. So then we look, similarly, we look now, instead of looking at each worksheet instruction, we look at individual questions within the worksheet to see what did the question actually ask the student to do. Similarly, was it active, did they act for active, constructive, interactive? So because we're interactive, we can't tell, we can only tell whether the question is constructive. interactive, constructive. And you get the same pattern. That is, they're pretty good for active classes. The questions are active, but for constructive classes, it's about 50%. And the same with interactive is about 50% for constructive, maybe a little bit better. Okay, how good were they designing assessment questions? They designed their own assessment question for the lesson they created. Well, they did design 97 recall questions on the left, and the researchers agreed those are 97 questions. They designed 69 inference questions, and the researchers agreed those were 72%. So they did pretty well, though this is really hard for them. Okay, now, let's talk to transfer to implementation. Implementation means they're standing in front of the kids, they're actually implementing this. The first gross thing to look at is, like a quasi-experiment, did they actually spend more time on unique activities? And after months and months of coding, the short answer is yes, they spent about 42 minutes versus 7 minutes on the unique activities. So at least you know there's a chance you might get the results. So, because they were experimenting. Okay, now we're doing the same thing with code the oral instruction from the videos. Instead of using verbs to code written, we code oral instruction. So again, we get exactly the same results. On the left hand, for active classes, they have a lot of active verbs, but for constructive classes, they didn't have enough constructive verbs, right? So, I mean, the constructive verbs should be over 50%, but they just weren't that good with constructive verbs. And one interesting thing that happened was, although they were so good at designing good questions, inference questions, when it came time to implementing in the classroom, whereas in real time, they converted a lot of inference questions to recall questions because they simply provided the answers, the materials for the answer. So we can't really look accurately at how well students learn if they were constructing or constructing because the answers were given away. That happens a lot. Okay, finally, let's look at student enactment. What did the students do when instructed under different modes? We coded 754 samples of worksheet. Had 7 people doing coding. It was a massive job. We could only code whether something was active or constructive because it was too hard to code interactive. Let me show you an example. So, for example, it could be because these are different activities. Some are concept maps, some are notes. The coding is very a serious undertaking. So, for the concept map, we circle what they wrote down and see whether it mapped onto something that was already presented. As I said, our definition is very literal and concrete. And we only give them credit for things that were generative, that they generated that wasn't there. So that prior student did not generate anything new, whereas this student did, because this information wasn't presented. However, we could not code for co-construction because here are 2 out products, right? So we can identify what's new on the 2 products, but we can't tell whether one person generated or whether it was really co-constructed. So that's a real challenge for us that we haven't resolved. Okay, now let's look at what students actually did for active classes, constructive, and interactive classes. As you see, for active classes, students enacted all actively. Even for constructive classes, they enacted mostly actively. Interactive class, they also enacted actively. So there's only 17% of constructive behavior in the constructive interactive class. So there's a lot of room for improvement. However, the amount of constructive segment was significantly greater in the constructive class, so that's good news. So that at least what we tried, they enacted more constructive segments. So these results suggest that students are not enacting the mode intended by the activity instruction, both oral and written. And one reason we thought is that oral and written instruction was skewed toward active, not only was it skewed, but also the instruction was given prior to the activity. So let's say you had an activity sheet of 5 questions. After you read the instruction, we thought, oh well, you might have forgotten about instruction. So let's look at individual questions within the worksheet. So regardless of what the worksheet was intended to be, we can recode each question and decide what mode it was in, just like we did earlier. We coded the question. So our student, the question is, the last one, Are students more likely to enact constructively if the question explicitly asks you for constructive response? And the answer is yes. So here, when we find this, compared to the last graph, there's a higher proportion of responses when the question is actually constructive. And that difference is also significant. So finally, we want to look at, did students learn? We already know that we cannot assess students' learning cleanly. I mean, this is not going to be clean because the teachers didn't design activities well, it wasn't designed at intended level, the instruction wasn't designed well, they distorted assessment questions, so ICAP can only be determined by a D question. The worksheet was not uniformly one mode or the other. So we know all these problems. So with all this problem, we are not expecting pairwise differences, right? For each class, for this teacher's class, that is the constructive better than active. We just can't expect that. And we didn't, about only a third of them were. However, what we can do is pool all the classes, all the active classes, all the constructive classes, just to see, and all interactive classes, just to see whether there's any hope of some significant difference. And here's what we found. We can't look at the passive, which is the leftmost, because there's only 2 classes. We can't look at the interactive because teachers were not given interactive instruction. So if we just look at the active construction, which we expect a big juncture difference, we did find a very significant result. So students' learning did improve, even though they only gave constructive responses about 17% of the time. But if you look more specifically, that's probably up to 50% of the time. So with a lot of room for improvement, despite a lot of room for improvement, they did learn more. So with all this assessment, we can see that only some of the stuff, only very few actually, measures that teachers actually were able to implement correctly. A lot of it is probably our fault. We're in the process of looking at all teachers' misunderstanding and revising our online module so that it's improved. So let me just conclude. So I've introduced a new framework. It does account for hundreds of studies. What it does show is that paying attention is the weakest form of engagement. And you may not know this literature, but there's a lot of current work on automated detection of paying attention. So that automated detection of student engagement is only detecting the lowest form. The other conclusion is that we try to translate theory of learning to theory of instruction in a potentially scalable way, so because we're developing an online module. Teachers have the weakest form of understanding interactive, and interactive presents a lot of challenge for us that we're trying to resolve. They also cannot design deep assessment questions, and we don't know how to teach them to do that yet. Students are typically likely to give active responses better than generative constructive responses, but despite all the distortions, the student did seem to learn significantly more across all these classes. Anyway, that's the huge remaining challenge. The other challenge with interactive, I want a measure that a teacher looking at a class, I don't want to use high-end technology. I want to develop a measure which a teacher can detect whether a pair of students are collaborating well or not, so that the teacher will go up and help. I have some ideas, but we're not working on that yet. So, thank you for your attention. Sort of and if you have time, I can show you one example of an activity that we picked from the YouTube that we show in a module to show you how teachers misunderstand what an active classroom does.